maybe you should spend less time focusing on his quotes and spend more time getting the cross-country team statistics like the second place. Less than 10 points.
Yeah, and third place is like.
His hands are always cold.
All right, listen carefully. This is what we're going to do. So when we get to somebody and they're not paying attention, they won't get credit. You're going to get credit for coming up here, working a problem out on the board. We're going to start with problem 12 and work through problem 19 and 21, however far it takes us, depending on how many people we actually have in the class. We're going to start right here with Austin, and we're going to go down this row, then we're going to go down this row, down this row. Nobody likes Peyton J. He's over here all by himself. Down this row.
Yeah, I'm gonna get the last one.
Yeah.
There's not enough.
Now, Peyton's saying, but he's going to be happy once we get to him. So I can see the hamster in Emma's head turning already. What's she doing?
See what one you have.
She's trying to figure out which problem she's going to have. Good idea. Because what's going to happen, I'm going to give you credit instead of me walking around and checking Austin's homework. I'm going to give you credit as you go up there and you do the problem. You get your problem correct, you get full credit. You come up here, you write something down. No. We're going down each row. You come up here, you get your problem wrong, you get half credit. Brittany decides, I hate Mr. Eversole and I hate that he's making us do this. I'm refusing to go up to the board, and there's some song out right now that talks about I threw my test in the trash in geometry class or something like that, and there's some stupid song out like that.
Google it.
What?
You don't know that?
No.
Something's wrong with that. That's like almost your age.
What's that song got to do with anything about geometry class?
For the bell and geometry.
Oh, Rebel, all right.
Yeah, Josh.
So, I'll give you about a minute, figure out what problem you have, make sure you got it correct. Don't just sit there and do nothing. Look at it. Even if you don't like the people around you. I don't like Robert a whole lot, but I could say, hey Robert, is this what you got for this one? Even though I don't like
You
him.
guys love each other so much.
So, I'll give you about a minute, do that. Again, you get up there, you get full credit if you got the correct answer. Half credit. You put up the wrong answer. Austin, will you do me a favor because I had this in my pocket.
Don't drop it.
And no credit if you just refuse to go up.
Good hands, feet.
Oh, sorry, Austin, do me a favor. Over on the, click the board with that other pin. Everybody watch. Just click the board. Click it again, because there you go. It gives you a spot to do number 12 right there.
Dang, I wanted the left side.
So problem 12. I'll give you guys a chance to help Austin out before I look up there. Tell him whether he's right or wrong. We'll do this for the whole class. You didn't have to write all that out, Austin. That's all right. You just like being in front of the class. So.
No, not
Try hard.
Everybody should be paying attention. Not messing around. Symmetric property, everybody agree with that?
Yeah.
What's symmetric property do to a problem? Switches. That's correct. Yes. Who? It says she's absent today. 13. Mr. Cook.
Dang it. I don't know what I'm doing. So I'm going to throw something out there to
So, you didn't ask nobody before you walked over here?
Yeah, you could have got an answer from someone at least.
If anybody believes
I
me,
asked someone how to do it, you, but
But, Josh, just put train.
you're the teacher,
Alright.
you're the best person to ask.
they change
Click,
that.
click.
Okay.
It'll change.
I've already seen this, there's why I asked.
There we go.
Is everybody watching, so we don't have to do that explanation again?
Yeah.
Nick knows that if he clicks the board, it'll probably pop up, what number, Nick?
15.
15, 14?
Let's see what the problem is. Just put trains in
All right. I'm getting there, Austin. Oh my goodness.
Maybe Matt will be in this dream.
Yeah.
told you I took a picture today.
You're not winning.
You don't have to write all that out.
Right there. Alright, just throwing this one out here. Oh,
You doing good, Josh? That makes sense.
Did I get it right?
So you asking me, or you asking everybody?
Hey, ask me, please, ask me.
I'm asking Rob.
Substitute.
Rob's our favorite substitute teacher.
Please trust me right
You
now.
don't trust Robert?
Please trust me right
I screwed
now.
up there.
Please get full credit, I'm helping you out.
Awesome, trust me.
I know, how do you trust me? I say trust me. Alright, please.
No.
Please just tell me
I don't
right
think
here.
it is.
It's the mighty Austin finally
He's trying to
That
make
was-
us mine.
That was a trick.
That was the trick answer. People.
That was a trick.
Trick answer.
Substitution. Dude, you should be a substitute teacher. For college, that way your college has
That's
that.
wrong.
That's
That's killing Austin.
No, that's all it is. I don't believe it.
You said you
Tell
trust
me I'm right, please.
Is that what you're going with?
Say yes.
Locking my answer.
Okay.
Alright, listen carefully.
Oh.
Everybody up here. They told us this. I don't even remember what it said, but it said something like AB equals 14, then CD equals 14 or something like that.
Yeah.
And they wanted us to prove that AB was equal to CD. Now, a lot of people want to put transitive property on this, but with transitive property, remember if I write transitive property up here, with transitive property, these middle two letters have to be the same. It has to go in that certain order for transitive property. So substitution property is correct. If you put transitive property on this, I probably wouldn't mark it wrong. I'd probably give you credit for it. All right? So it doesn't really fit transitive property, but could I flip these two around and make that 14 equal CD, then use transitive property? So you'd be using symmetric property, then transitive property, and it still sort of comes out the same.
As is.
All right, but as is, what the answer, the best answer, the answer that they wanted was substitution. You just took these two things, you said, hey, look, both these equal 14, so these two, I can substitute them in and put substitution there. Number 13, Nick. Brian, I'm not gonna, or 14. Brian, I'm not gonna have to yell at you for messing with people, am I?
Yeah, Brian.
So
You
stop,
probably got
please.
the hardest one out of these.
Alright, Nick.
What?
You probably got the hardest one out of these little.
Mr. Everpool, you're adding a lot of stress onto my life.
I've been eating celery.
I'm gonna go to pressure, I'm not gonna eat at lunch.
Blood sugar.
I mean, blood pressure.
Dude, it's fine. Sorry, it's
Sorry, my don't
Who
add.
wants to do cakes or something?
The period matters, Nick.
Sure.
Work out.
And you gotta ask your classmates.
Ask your
No,
peers.
no.
Peers, is that right? Hey.
Go boy, Skipper.
It's it.
You're locking it in. You sure?
Hold on, wait.
What
What number was yours? 14.
What is addition problem for
So
5.1?
Robert, on this one, ignore Austin.
It's not that, but I don't know what it is. I'm not gonna lie, I don't know this one off the top of my head.
I know it's like.
I love having this bar right here because
I'm not very.
I know this is the one that I don't know. When they gave it to me, it just seems.
You should have been 15.
you can't lock it in twice.
You can break the lock in and then make another one.
You take the lock.
Go through the room segment.
Is that what you're going with this time?
Yes.
You sure?
Yes.
Alright,
You got three.
positive.
I'm positive.
Deal or no deal?
Alright, we gotta hurry, you guys are taking way too long.
What?
So, on this one, everybody agree with segment addition should be a property?
Fellow peers.
It's not a property, it's a postulate, segment addition postulate. I won't take on for that, but. Is that what everybody thinks?
Agreed.
Yeah, this segment plus this segment should equal the whole thing. What's collinear mean? Same line. So all those points are on the same line, probably to help you out with this one, because I'm sure a bunch of you had trouble with it. What should you do?
Nothing.
What should you do?
Is there any chance I could get like 3/4 credit if I put 2 answers up there and one of them's right? Are you sure?
What should you do if you don't know how to do the problem?
Ask your peers.
Yeah, that's true, but
Educated guess.
draw a picture. Should draw a picture. Number 15. All right, Brian.
Oh, yeah. Well,
I'm gonna draw a picture.
Drop the cat.
We don't need all the extra chatter, so no more. Let's hurry up and get through this. All you gotta do is be paying attention, help your peers out when they're up there.
I don't know how to spell it. I don't care know what.
oh my goodness.
Was it already on the board somewhere? No.
No.
What was he doing? 15. Good job. Can I ask my peers? Good job. Is that right, Robert? Alright.
I'll answer that.
Everybody's agreeing with that? Sure.
We locked in.
I agree.
I locked in.
Alright, what's different about that one than the one, that Josh did? Why is it different?
Yeah.
It goes in the correct order.
Correct order.
Alright, so make sure it goes in that correct order. 16.
Darn it, I hate my life. It's the easier. So can I know, but I just feel like I don't know it, but I'm nervous. I'm really nervous, Mr. Cooks. Just gonna go for it. I don't trust myself on this. I really don't know. It's
Make a
like
guess.
it's like segment, addition, or transitive. I've heard multiple answers.
Look at it, Robert, you're smart enough to get this one. Look at what they did.
Probably.
Ask your peers, maybe they'll help you.
Ask Austin.
I don't like my peers.
Austin, what did you get for 17?
These peers don't know.
I just want that. I'm just gonna go for it. You ready?
Segment.
Segment
addition.
I was leaving space just in case.
You make weird E's.
I write backwards. Is that?
I think it's a postulate.
Yeah, that's what I was.
Toast.
Seg add post.
Show me an example of the segment addition postulate up there.
Oh, Lord.
I really dislike the line.
Somebody's gonna be upset here in a minute, I'm gonna start handing out the tens.
I don't really know how to do it. It's like
Segment addition postulate is
Oh, see at the end. The plus signs in between.
Now, it's not A. You can't measure
Line
point A.
A.
Segment AB plus
BC.
There you go.
equals what?
AC.
Is that what they have in the book for this problem, Robert?
No. Well, yeah, kind of. No, not really. Yeah.
No.
I'm lost.
So, how do you
Hey,
want to
look
change
in the
it?
example.
I don't wanna change
Look
it, I
in
don't know.
example number one.
Example 1.
Yes, number 3 in the state.
What page is example 1?
1 and 2.
Yeah, I thought I missed it.
Not number 3. Maybe number 2.
That was my first answer. That's what's written on the thing.
So you should look with what you believed in.
I don't believe in myself.
Believe in yourself, Robert.
I don't believe in myself.
Everybody see that?
I'm gonna go home.
Listen carefully so you understand this. What did they do in 16? Was it this segment plus this segment equals the whole segment? No. They told you these two segments are the same, these two segments are the same, and then they said, well, if I add this to both sides, which is the addition property, we should get the same thing. So just addition property, they just added the same thing to both sides. 17.
Robert, why is your eye
Oh, Lord.
I didn't write the I.
I have to.
Or the 2. Or the chains.
Okay. So, I'm not good at this stuff at all.
Try.
So, this is kind of a peer-based thing.
Hurry up, let's go.
Okay.
Hey. Good job, buddy.
Josh and Nathan. I just saw probably written down.
What else could it be?
There's one thing that.
Hey.
Okay,
Is it?
Trust me.
there's plus signs in it.
Please trust me. I'm begging
How can it
Brian,
be subtraction? There's plus
begging
signs in
you.
it.
I am begging you.
There's plus signs in
Just
it.
trust me. I'm begging you. Please.
I'm gonna get half credit either way, so.
Yeah, I'm telling you. Please.
But it could be a transitive property.
I'm begging you, Mr. Eversole. I'm in the point where I'm a Mr.
I was right. You're on the pool. I'll teach you that.
Is,
Alright, you got half.
yeah,
Tell me you got half there.
Tell me.
love getting the answer.
Are you done? Are you done? Take a seat, sir.
Yeah,
Take a seat.
okay. Sam is no longer gonna talk.
That's the.
Alright, on this one, transitive property, everybody agree with that?
No, yeah, subtract.
Yes.
Robert, do me a favor, go up and push the button so you can turn it on. Listen carefully. You just got.
Top or bottom one?
The indented one, the bottom. Yeah, point it towards the board. There you go. Alright, listen. We might take a test today. You guys not paying that much attention like everybody knows it so well. Problem 17. Does that look like transitive property?
It does, but that was my first look at it, but then I
Is
looked
it
at it
segment
closer.
addition?
Just
The segment
I said
addition.
try.
Now, if it's segment addition, it'd say this plus this equals some other longer segment, right?
Yeah.
Look at it. What did they do?
They took out the.
They took out what?
J.
They
Yeah.
took out J and K on both sides. So what is it?
Subtraction.
Subtraction.
Robert, I should have listened to you.
Subtraction property.
Oh.
Does everybody see that they took J and K away on both sides?
Yeah.
Don't let that confuse you when they start using segments and angles instead of numbers. They just subtracted the same thing on both sides. Alright? Number 18. Marissa, I'm going to do you a favor, and it's going to mess with everybody else. Well, You don't want me to? All right, go ahead.
What, she's only doing A, right?
I was just gonna have her write the problem. Yeah. I was gonna have her write the problem and then start with
Yeah,
A.
that's why I wish I sat there.
No, I don't.
We just switched problems.
No, I wish I sat
Click it
there.
again.
I just realized.
Erase everything for us.
Emma, should I people watching this video won't see what we ever wrote?
Watch your ears, right?
Listen, do me this favor though, draw the picture up there that they have. I've clicked it too many times.
How do I go back?
Watch me rename.
Is what, do you mind?
Drop the bass.
Go back to the 25th.
I'm telling you, I'm gonna walk by my desk, I'm picking up detentions. There's no reason for all the chatter. Somebody go ahead and draw your 2 columns. Somebody help me out and tell me what the letters are.
There's,
B,
Yeah,
yeah.
there's a, what,
Yeah, the D's right there. Then E, plus the E. C.
C.
all right. So that's the given information. What I want you to do, anytime you're doing a 2-column proof that's geometrical, like this one, segment AD is congruent to segment CE. So I come over here, what should I do in my picture?
Make the right line.
Make the little tick marks on it. AD congruent to CE. All right? I want you to do this and think it through before you ever start to do the 2-column proof. I don't like the ones where they have you fill in the blank, because do you stop and think it through before you start filling in blanks? No, you want to jump right on it and then nobody understands how to do a 2-column proof. You've got to come out here and think it through first. Thank you, Bruce. Segment DB is congruent to segment EB. What do I do there then?
You do 2 little dashes.
Do 2 little dashes on it. Everybody see that much? Now, before we go any farther in this, let's think it through a little bit. I got this segment's congruent to this one's congruent to this one, and we're trying to prove that this whole thing is congruent to that whole thing. What could we do there? Add these 2 parts together. What's that going to involve? You guys have been trying to use this over and over and over again. Segment addition property. Guaranteed somewhere in this proof, we're going to use segment addition postulate, not property. Segment addition postulate. We're going to say this plus this equals that whole thing. This plus this equals that whole thing. All right? Then, if these 2 were the same, these 2 were the same, these 2 were the same, we add these 2 together, we add these 2 together, what should we get? What should we know about those 2 longer segments? They should be the same. All right? Anybody know what property we use there? A couple different ones I would accept here.
What?
If I say this plus this equals the whole thing, this plus this equals the whole thing, how could I then say that this whole thing equals this whole thing? What property? I would probably, substitution's the best answer. I may accept transitive property there, depending on how it's written, because you might be able to write it so that this equals this, which equals something else, but substitution is probably the better of them. All right, next part on this one. Now, did I say this last time?
No.
What Brittany's getting ready to do here? I think I did in this class. I think I forgot in my other class. But I think you guys, I did it. We'll see if she writes it down, unless she's just real intelligent and figured it out on her own. Yep. All right, so up here on this one, all they did, what's different from step A to step B? What's the only difference?
The congruent
and
symbol.
All right, the symbols. Congruent equals, they just changed it. All they're doing there, and we'll do this for this section and next section, then we're going to be done with it, because I don't care about that. You understanding that there's a difference between geometry and algebra as far as being mathematically correct on something is sort of ridiculous. I'd much rather you know what a midpoint is, what supplementary angles are, what vertical angles are, so on and so on. So all they're saying here is if you go to prove some big mathematical theorem or something, you got to know that there's a difference between geometry form and algebra form. And we can just give that reason, definition of congruent segments, as the reason. Now, on down this, one of you is going to have to use this somewhere else down through there. And I bet if you look down through there, you can probably tell which reason is going to be that same thing that Brittany just wrote up there.
Go Corbin.
Oh, the other thing I should have said while Corbin's doing his, you see how they put all the given in one statement up there at the beginning?
Yeah.
I would much rather you did not do that. Make two separate statements and write the word given out there twice. All right? All it's going to cause you is to have to write 5 extra letters, given. But on like a test, when we take the test this week over this stuff, that gives you 2 extra points. Because I give you a point for each step, or each statement and each reason.
Anybody disagree? So I can get full credit.
I disagree.
What do you think?
Still, I wants to help Corbin out.
I agree fully, Corbin. That is fantastic
Alright.
mathematicianship right there.
Be a teacher.
Logging it in.
All right.
If Robert.
So what did you do? Look up here. Let's see if Corbin's right. Here you had AD equals CE. Got AD and CE there. What'd you add to this side?
DB.
DB. What'd you add to this side?
CE.
What did you know about those two? What'd you know about them? They're equal. So did you add the same thing to both sides? Yeah. So is that the addition property? Yeah. You just added the same thing to both sides of the equal sign.
Go Weston. You got this.
Next week it says, give you the reason you gotta. We sort of explained this one to you.
It's probably wrong.
Somebody stuck crayons.
Every answer they get straightforward.
There's crayons on the back.
Yeah, that's because I turned.
Is that what you're going with?
Anybody think that's wrong? Awesome.
Josh, right?
Everything I see
Did,
is
right?
good.
That's what I got listed.
Yes, Robert's got like everything right so far, so I'll go with that.
Everything says good. Alright, let's get that half credit.
I'm only
All right, listen carefully. This is probably the hardest one because just what they did. If they would have given you this and said segment addition, and you had to figure out segment addition, that'd be fine. Now this one, they put them both in the same step, and not much you can do when you're filling in the blanks. So there's not an extra step here. I would separate them, but that doesn't really matter. Segment AD, let's go over here and look at this. AD plus DB equals AB. Everybody agree with that? This segment plus that segment equals the whole thing? Is that by segment addition postulate? All right. CE plus EB equals this whole thing. Now, before we go, so I don't have to walk back up here again, when you're doing a two-column proof, look at your steps. Did this right here lead us to this second one? Yeah. All right? And that's what it's going to do. It's going to lead you. One thing leads you to another, leads you to another, leads you to another. All right? Look at what we had in C here. You see that anywhere else? Oh, it's right here, isn't it? Look at what we have right here. You see that anywhere else? What do we know about those two things? What did we say up here? They're equal to each other. Well, then what do you think we're going to be able to say about these other two parts? Oh, they're probably equal to each other, aren't they?
So, was that full credit or?
Yeah.
Go Weston.
You're going back.
What's the answer? Oh, 22nd today. It's today.
Yeah, because you don't do anything. No, he has me like listen to the videos of Mr. Bryant. He doesn't really do anything.
Who's yelling at all this? Peter Evans. I was mad.
I was talking Max.
Was it that?
Death of Tom's sake.
What is it that he eats? What if he did it symmetric property?
What's symmetric property do?
Flips it.
I think it's reflexive. Or is it,
What's reflexive property do?
which means A equals A, so those two equal the same thing.
Remember, A equals A, those
That's
are
that's A equals
Yeah.
itself.
It's got to be something equal
Oh,
to
then it
itself.
is symmetric.
Substitution.
God dang.
Substitution.
Yes.
There you go,
Substitution
buddy.
Is that right? Substitution property?
Who you asking?
Right.
You.
You're asking the wrong person, because if I answer
He's not
right-
here.
Good, ask Austin.
Oh,
Ask
Austin.
Austin. Either that's Robert.
Robert's got it. If I answer right now you got a blank answer up there, and I
Just
would.
kidding.
Just kidding.
So,
Josh, I want to have 4 monitors on this computer. It's not a cool iPhone graphics cards.
Now I'm asking you.
Now you're asking me?
Now I'm asking.
So you're finished, right?
Powers.
lock it in. Click
Yeah.
your pen.
Lock it.
Here.
Does everybody agree with that, substitution?
Yes.
That's correct.
Simulator.
So, substitution property. All you did was you knew that those two things were equal from step C. Then those other two parts had to be equal. Peyton was over there sweating it out when you wrote that first thing up there, I bet. Thinking, oh, what? No, that means I'm wrong.
It is so stupid.
I was just saying,
Work it.
14, 23.
Now, how come Peyton wrote that? What did you do?
You told us that there'd be no.
Well, yeah, and because
What did it do?
it just took it's just saying that this is the same as this.
Alright, so it went from algebra form, which is the equals form, to geometry form. Alright?
Let's take a test.
No, not today.
Yeah, sure.
Got about 20 minutes.
I mean, we can do it. Do you really believe with God and everything's possible?
God,
Does everybody sort of understand those?
a little bit.
Getting a little better?
I'm hazy on
Right.
stuff. Like,
You've got to go through, number one, you've got to think things through first. If you don't think it through, you're probably never ever going to understand any of it. You've got to go through, draw a picture, think it through, and say, all right, what am I going to do here? If you don't do that, you're going to be lost. Use your steps as you go down through here. Say, all right, how do I go from this to this? And again, as we go through the year, we're not going to put this step, this one, we're going to do away with it. This one, we're going to do away with it. So then the final reason down here would just be substitution. We're not going to switch from algebra to geometry and geometry to algebra. It's just sort of silly to keep doing it. It's nothing that, unless one of you, which I hope you do, but unless one of you goes on to be some great mathematician that travels around the world and does all these mathematical things like an Albert Einstein, you probably don't have to be that precise about everything. All right? Even Peyton's dad, being the great mathematician that he is,
the greatest trash
Doesn't worry about-
in the world.
doesn't worry about switching them.
Go everywhere.
Yeah, his helicopter that goes Mach 1.
All right, this is the start of your notes. You can title this. I'm going to do this for you, this 2-column proof, just so you have something in your notes there. You can title this, I know this won't make sense, proofs with angles. Well, we're not dealing with any angles right here at this point, but we're going to get to it here in a minute.
Yeah.
All right, on this, we're given that segment AB is congruent to segment CD. So what should I come over here in my diagram and do?
Throw it out.
Those two segments are congruent. Put some tick marks on there. All right? Now, we're trying to prove that this whole segment from here to there is congruent to this whole segment from here to there. How do I get from segment AB to segment BC? Or how do I get from segment AB to segment AC? That's what I meant to say.
Just go through it.
What did you do to go from this segment?
Okay, you add them.
You added what?
A, B, C plus BC. Does that work?
Plus you added on a BC, right? You added on BC. So here, what I'm going to do, I'm going to take this segment and I'm going to add segment BC to it to get this whole thing right here. What do I do to get to segment BD? How do I go from this part, just that part right there, to the whole thing BD from here to there? You add what to it? What did I add to that CD to get to that new longer segment?
BC.
BC. Does everybody see what's going on there? What did I do? What property did I use there? Addition. I just add the same thing to both sides. I add the same thing to both sides. Should I get something that's equivalent? Yeah. So I should be able to say that these two are the same. Statements, reasons. What's our first statement going to be?
for AB.
It's a gift.
Segment AB is congruent to segment CD. Now, again, this is where the book would differ from me.
Because they would use letters instead of numbers.
Well, what they would say, well, yeah, that's true, they would use letters there. But then the next step that they would say,
Is AB is equal.
AB is equal to CD without all the symbols in there. I'm not going to do that. All right? What can I do next?
Or AB, or
Segment AB plus
BC.
BC equals what?
Segment CD.
AC. How did we know that? Segment, addition, postulate, or probably even a better thing there
What?
is you could put that, you could just put addition property.
So it's
All right, so you could put addition property there. Actually, we could change this. I don't know. Might be a better way to do it. Easier way, maybe.
it's just.
Sorry. Let's do it this way. This might make more sense to you. What you just said, segment AB plus segment BC
Equals CD plus CD.
exactly. Let's go this way. CD plus BC. Now, the reason I think this is going to make more sense this way, what did we add to both sides?
That's what I was gonna say.
We just added BC, and now we just use what? Addition property.
That's the first thing I said.
Sorry, Robert, I should have listened to you. Next time I'll make sure I do.
Time man, Robert is a genius.
Now, third step. Now let's go to this, what we were going to say up here. Segment AB plus segment BC equals segment AC, and we can do this in one step so you don't have as much writing since I screwed up. So what's the other part going to be?
BC plus CD.
Segment
CD.
CD plus BC. Pen quit writing. Equals what? DB. Yeah, wait, BD. I just wanted to, how come I said BD instead of DB?
Makes more sense. It's easier to left to right, I don't know.
Because they've already got it up here, so we don't want to turn it around and confuse anybody. How did you know that this plus this equaled the whole thing?
Oh wait, no.
Now that one is
Segment.
segment, addition, postulate. Wine after you leave my class, Brian?
Huh?
Wine after you leave my class. Now, look at what we have here. We have, you see that part anywhere else in this problem?
Yeah.
Where?
Step 3.
See this anywhere else in this problem?
Yes,
Where?
Down in step 3.
Scribbles.
So now we knew that this was equal to that. So these two are equal. Well, what do we know about these two then? They have to be equal. And I should have used congruent, not equal. It doesn't matter really. So what am I going to write? Two. Be careful here. This one seems to confuse a lot of you.
Substitution.
Exactly, substitution. Substitution property. Now it's
Substitution.
it's substitution.
Because you substituted AB, BC, AC, and you substituted CD, BC, and BD.
So what you're doing, look, Peyton, you knew that these two, this whole thing was equal to that whole thing, right? Well, both those are right here. So what we're going to do, we know that this one, we know that this equals AC, right?
Yeah.
So in place of this, we can take this out and put in AC, in place of this, we can,
Oh,
you see what I'm,
Yeah.
you sure?
okay. You just
So, you're saying that these two things are equal,
putting that
so we could take out
in place.
this right here and put AC right in its place.
AC. Right there.
Oh, okay.
These two things are equal, so down here, we're just gonna take this one out, and we're gonna stick in AC in its place.
Wow.
Okay.
That makes sense?
Mhm.
Are we finished?
Yeah.
No?
Yeah.
Is that what we were trying to prove?
Yeah.
Yeah.
Oh, never mind, we didn't take it.
And just add this to, you can just add this to what we were just doing. Again, that proof, I just wanted it in there so you got something to look at, to try to get an idea.
You got your own traffic jam.
Yeah, we're gonna have days like this, say we're everybody.
Yeah.
You've never done that.
Wow, I'm having such a rough day.
Yeah,
I'm finding it's 37.
she's 35.
I'm having a rough day because I'm not explaining crap.
Right.
Claiming that well enough.
She's old enough to be your mom.
Alright, write formal proofs involving angles. Formal proofs involving angles. What we're going to do, we got like 17 minutes, so we're going to go sort of quickly. What's a formal proof again?
Statements.
Two column, right?
Yeah.
Another name for a formal proof is a two column proof. What's another name for an informal proof? Paragraph proof. Very good. So it's a good thing we don't do as much of them, right? All right, what we're going to do, start a class, you wrote down a bunch of postulates and theorems, and what I'm going to do is go through them.
You don't need to rewrite this.
Yeah, you should rewrite it, because this is like my explanation. Anything I put on here, this is my explanation of each of those theorems.
Wait, this has to be on our postulate.
No, this should be in your notes. Anything I put up here is notes. This is just like an explanation going through all those rules that you wrote down. All right? So this is your notes for today. Why I keep writing that? I don't know. So this is your notes. The first one, postulate 210, is the protractor postulate. Remember the ruler postulate from last week? Protractor postulate, basically the same thing, except the ruler postulate I thought was sort of silly, because all of you should know how to use a ruler. Protractors, maybe you don't know as much. Got a protractor? On this protractor, it's got a dot right in the middle, and all you do, what the protractor postulate's telling you, you line up that dot with the vertex, and then there's a line on the bottom of the protractor, you line up it with one of the sides, and then the other side comes out here somewhere, the other side of the angle. Whatever number it matches up to, that's the measure of your angle. Now you've got to be careful with this, because on most protractors, how many numbers are there going to be right there?
There's two.
There's two. One of them's an obtuse angle, one of them's an acute angle. So you got to look at your angle and say, hey, I know my angle's the acute one, so it's going to be the smaller number. Or maybe you have, this is your protractor, maybe your angle goes like this. Then it's going to be the obtuse number, it's going to be the bigger number. All right? So that's all it does. Protractor postulate just shows you how to use a protractor. Hopefully.
It's like math walls.
Yes, or postulates and theorems or rules. All right, the next one, 211. I grab my book so I can remember what's the teeth. Robert, get back on track. Sorry.
A big jail.
211 is angle addition postulate. Angle addition postulate. Just like this segment addition postulate. Remember, the segment addition postulate says this. If I wrote this up here, Robert's going to help me out because he couldn't do this a second ago. Tell me the equation you could set up from that segment that I drew there.
A plus B.
Nah.
AB.
Segment AB
Alright.
plus
Segment BC.
BC equals.
Segment
the whole
AC.
Now watch. This is what the angle addition postulate does. Now don't think, I hear people saying bisector. Don't think, do we know right now that BC bisects that angle? No. But what we do know is that angle ABC plus angle
CBD
CBD
equals
has to equal what?
ABD.
This whole thing. Angle ABD. Right? So this angle plus this angle equals the whole angle. Nothing real difficult about that. Same as segment addition. You're just using angles. This angle plus this angle should equal the whole angle. Theorem 2.2. Now all these theorems, what's different about a theorem and a postulate?
Theorem has to be proved.
Theorem has something that has to be proven, so it should be a little tougher, right? And the postulate's more common sense. Theorem's something that you gotta actually prove is true. This one's called the supplement theorem. What are supplementary angles?
Two angles that add up to 90.
No, 180.
Two angles that add up to be 180.
He's bright.
Now, what this one says. And I don't want to write it up here. I'm going to write it right here. If you have these two angles, those two angles together form a what? Linear pair. So if you have a linear pair, then angle 1 and angle 2 are what to each other? Supplementary. We already knew that, right? If you have these two angles, they form a linear pair. We know also that they're supplementary to each other. Remember the second 9 weeks, stay on it. Because you know how much you turned into me on Friday, right?
None?
Oh.
I never forgot, I'm sorry.
Theorem 2.4. Theorem 2.4 is called the complement theorem. Two angles are complementary. What's that mean? Two angles complementary, they add up to be 90. This one says, if you have a right angle, so if we have a right angle here, and we draw in another ray there, and now we have angle 1, angle 2. What do you know about angle 1 and angle 2?
They add up to 90.
They add up to 90, so they're what kind of angles?
Okay.
So then angle 1 is complementary to angle 2. Again, I know that seems like common sense, and we've been doing problems like that already. Theorem 2.5. Ah, you stupid thing. Theorem 2.5. Let's write these three properties down again. Reflexive property. What's the other ones that go with reflexive property?
Symmetric.
Symmetric, transitive. Good. Symmetric property, transitive property. all 2.5 says, we went over one like this the last class. Only the one last class was dealing with segments. Theorem 2.5 says that all three of these properties work for angles just like they work for segments and they work for algebra. All right, so it's just telling you that these all work for angles also. What's a reflexive property say?
A equals A.
A equals A in algebra, right? So when we're dealing with angles, it's going to say something like this. Angle 1 is congruent to what? Angle 1. Reflexive property says anything equals itself. Symmetric property. Angle 2 is congruent to angle 3. What's symmetric property do? Angle 3 is congruent to angle 2. It just turns it around. Transit property would say something like this. If angle 6 is congruent to angle 7, angle 7 is congruent to angle 8, then we know what?
The 8 is congruent to 6.
Alright, so angle 6 is congruent to angle 8. So they're just telling you there that those are the same, or that they work for angles, segments, and all the algebra stuff. Anybody confused about that? Weston confused about any of that? It's pretty easy stuff, right? Now we're going to get to the harder stuff. Reflexive property, real important. Make sure you remember that. Anything is equal to itself. Don't get confused like some of you did at the beginning of class. But it says angle 1 equals 50 degrees. Is that reflexive property? No, reflexive property says angle 1 equals angle 1. It's got to be exactly the same. Right, theorem 2.6. These are a little harder. Theorem 2.6, and I'm going to write the abbreviation up here so that when you're using this as a reason in a 2-column proof or whatever, when you're using this as a reason, you can write this shortened form. Angles supplementary to congruent or the same angles, or the same angle, are congruent. And I know that probably doesn't make a whole lot of sense yet, so I'm going to draw something up here for you.
Wait, what is that letter after the congruent sign? After the first one?
OR, or.
She says them.
Could be. All right, if I give you these pictures and I tell you angle 1 is supplementary to angle 2. All right, so everybody, we know that these two angles add up to be how much together? 180. And I tell you angle 3 is supplementary to angle 2. So you know they add up to be 180. What's that tell me about 1 and 3? They have to be the same. They have to be congruent. That's all this theorem says. All right? If you got two angles and they're both supplementary to the same angle, then those two angles have to be congruent. Now, the other part of it, where it gets confusing, that part right there, is if they give you another angle out here, and they say, all right, angle 1 and angle 2 are supplementary, 3 and 4 are supplementary, 2 and 4 are congruent to each other. Well, then what's that say about 1 and 3? They have to be congruent. 2-7. 2-7 says the same thing, but about complementary angles.
We reached an hour. Recording.
So complementary, it's going to say, of course.
You were so thrilled.
Angles complementary to the same angle or congruent angles are congruent. So if you got two angles and they're complementary to the same angle, then those two angles have to be congruent to each other. And we could draw a picture just like this, except with angles that add up to be 90. Angles complementary to the same angle, or I got to put using cursive because nobody can read my cursive. I can read. Or congruent angles are congruent. Two eights. 2-8, very, very important. Apparently not. Easiest one we're going to do all year. Vertical angles are what? Congruent. You draw your picture. What do we know about angle 5 and angle 6 right there? They're vertical and they have to be congruent. That's all Theorem 2.8 says. Vertical angles are congruent.
There's one thing I know like it's that.
The others, because we're going to run out of time. Remind me next time and we'll write down stuff for 2.9, 2.10, 2.11, 2.12, 2.13. Maybe I'll start class with it. But they're not very difficult. The one says two angles are perpendicular. What's perpendicular tell you? They form what? Right angles. That's what it tells you. Alright, so it's a lot of going through that.
It's the assessment.
Theorem 2.9 says perpendicular lines form four right angles. So all it's telling you is if you got two lines, they intersect each other, and they tell you that they're perpendicular to each other, then all four of these angles have to be right angles. Theorem 2.10. Theorem 2.10 is a real simple one. All right angles are congruent. So if you have angle A is a right angle, angle B is a right angle, they have to be congruent to each other. Theorem 2.11. Perpendicular lines form congruent adjacent angles. In other words, you got two lines and they're perpendicular. Angle 1 and angle 2 here, those two lines are perpendicular. Angle 1 and angle 2 are adjacent to each other, and they're also both right angles, so they're congruent to each other. They form congruent adjacent angles. 2.12 says if two angles are congruent and supplementary, so if two angles congruent and supplementary, then they are both right angles. So if you know that two angles, angle 1 and angle 2, are congruent to each other and they're supplementary to each other, the only way that works out is if both of them are 90 degrees. The only thing that will add up to be supplementary, add up to 180, and be equal to each other is 2 90-degree angles. And 213. If two congruent angles form a linear pair, then they are right angles. So if you have a picture, it looks like this, and they tell you these two angles are congruent to each other. Those two angles are congruent, and together they form this line, then that means both of them have to be 90 degrees. It's the only way it works out. All right, we're going to try these problems 3 through 7. Try them. I'll go through and help you, and then we'll probably go over them. Your assignments on page 112, 16 through 24, 27 to 32, 38, and 44.